binomial expansion or binomial theorem. So let's talk about a binomial first, an algebraic expression having exactly two terms is called a binomial. Now let us observe the expansions of a binomial with different exponents. So let us consider the simplest binomial form, that is a plus b. If the exponent is 1, obviously this is a plus b simply. And if we take a plus b whole square, and it can be expanded as a square plus 2ab plus b square. Now let us consider a plus b whole cube. So that is equal to a cube plus 3a square b plus 3ab square plus b cube. So let us observe each of the above equations one by one. Let it be equation 1, let it be equation 2, let it be equation number 3. So from equation 1, a plus b is to the power 1 is equal to a plus b. As we know well, 1c0 is equal to 1, so 1c1. That means the value of 1c0 and 1c1 is equal to 1. As we know well, ncr is equal to factorial n upon factorial r factorial n minus r. So if we replace n by 1 and r by 0, simply we have 1c0 is equal to factorial 1 upon factorial 0 to factorial 1 minus 0, which is equal to factorial 1, which is equal to 1. Factorial 0 is also equal to 1, so that is 1. And factorial 1 minus 0, that is 1 again, so factorial 1 is 1. So that is 1 upon 1, which is equal to 1. Similarly, we can show that 1c1 is also equal to 1. So in this expression, as we know well, the coefficient of a and b are 1. In the first term, we may write 1c0 in place of 1, and the second term, we may write 1c1, and so we may write this expression as a plus b raised to the power 1 is equal to 1c0a plus 1c1b. That will be equation number 4. Now from equation 2, we have a plus b whole square is equal to a square plus 2ab plus b square. Here we know well 2c0 and 2c2 are equal to 1 both, and 2c1 is equal to 2. So this expression may be written as a plus b whole square is equal to 2c0 a square plus, in place of this 2 we may write 2c1, so 2c1 ab, and here the coefficient of b square is 1, so here we may write 2c2 because that is also equal to 1, so 2c2 b square. That will be equation number 5. Now let us consider third equation, which is a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Since 3c0 and 3c3 are equal to 1 and 3c1 and 3c2 are equal to 3. So this expression may be written as a plus b whole cube is equal to, in the coefficient of a cube here is 1, so in place of 1, we may write 3c0 a cube as it is, plus here the coefficient is 3, so in place of that 3, we may write 3c1 because its value is 3. 3c1 a square b, plus in place of this 3, we may write 3c2 because that is also equal to 3 ab square, plus, and in the last term the coefficient is again 1, so in place of this one we may write 3c3b cube. So let it be equation number 6. Now, in order to generalize expansion for exponent n, let's observe the above discussed expansions. So from equation 4, 5 and 6, we have a plus b raised to the power 1 is equal to 1c0a plus 1c1b, and a plus b whole square is equal to 2c0 a square plus 2c1 ab plus 2c2 b square, and a plus b whole cube is equal to 3c0 a cube plus 3c1 a square b plus 3c2 ab square plus 3c3 b cube. If we observe these three expansions, we get the following points. First, the prefix of coefficient of every term is same as the exponent of the binomial expansion. Exponent is 1, so here the prefix is 2 in both the terms. Here the power is 2, the prefixes are 2, 2, 2. Here power exponent is 3, here prefixes are 3, 3, 3, 3. Second point which we observe, that is suffix of the coefficient of first term is always 0. And that goes on increasing by 1 until it reaches the value which is exactly equal to the prefix or exponent of the binomial. Third point is the exponent of a is equal to the exponent of the binomial, and it goes on decreasing by 1 term by term until it reaches 0. Here the exponent of binomial is 1, so the power of a is 1 and it decreases by 1, so the power of a will be 0, and as you know well, anything raised to the power 0 is 1, so that's why we have not written a over here. Exponent is 2, the exponent of a is 2 and it decreases by 1 in each term. It becomes 1 now, and in the third term it becomes 0, and a raised to power 0 is 1, that's why we have not written. The exponent is 3, the exponent of a is also 3 and it decreases by 1, it becomes 2, it becomes 1, then 0. Fourth point, we observed the exponent of b is 0 in the first term. Everywhere the b is not here in the first term, so that means the exponent of b is 0 in the first term in each expansions, and it goes on increasing by 1 term by term until it becomes exactly equal to the exponent of the binomial. So keeping all these points in our mind, we may write an expansion for a plus b raised to the power n as follows, is equal to nc0 a raised to the power n. The exponent of b is 0 in the first term and the exponent of a is equal to the exponent of the binomial, and prefix of coefficient in every term is n, and suffix in the first term is 0, so it becomes nc0 a raised to the power n. Now the suffix of the coefficient will go on increasing by 1 in term by term, and the exponent of a will go on decreasing by 1, and exponent of b over here is 0 and it will go on increasing by 1 in each term. So in the next term that will be nc1 a raised to the power n minus 1 into b plus nc2 a raised to the power n minus 2 b square plus nc3 a raised to the power n minus 3 b cube plus so on to ncn minus 1 a b raised to the power n minus 1, and the last term will be ncn b raised to the power n. Now here the exponent of a becomes 0, and as we know well, so this expansion may also be written as a raised to the power n, because nc0 is always equal to 1. So a raised to the power n simply, and in the next term we have nc1 a raised to the power n minus 1b plus nc2 a raised to the power n minus 2b square plus nc3 a raised to the power n minus 3 b cube plus so on to, and in the last term as we have ncn, and ncn is also equal to 1, so we may write only b raised to the power n. If we simplify these coefficients like nc1 and nc2 and nc3 and so on, so this expansion may also be written as a raised to the power n plus n, the value of nc1 is always n, a raised to the power n minus 1b plus the value of nc2 is n minus 1 upon factorial 2 a raised to the power n minus 2 b square plus nc3 will be equal to n minus 1 n minus 2 upon factorial 3 a raised to the power n minus 3 b cube, and so on to last term is b raised to the power n. Now let us talk about general term of the expansion a plus b raised to the power n. So as we have derived this expansion, a plus b raised to the power n is equal to nc0 a raised to the power n plus nc1 a raised to the power n minus 1b plus nc2 a raised to the power n minus 2b square, and plus so on to ncn a raised to the power n. So the first term is nc0 a raised to the power n, which may also be written as nc0 a raised to the power n into b raised to the power 0, because b raised to the power 0 is 1. So this expression may be written as this, and that is t1, that is first term. The second term nc1 a raised to the power n minus 1 b, this may also be written as nc1 a raised to the power n minus 1 b raised to the power 1, because b means b raised to the power 1, and that is t2, that is second term. And the third term is nc2 a raised to the power n minus 2 b square, that is t3. So if we observe, prefix of the coefficient is always n, and the suffix is predecessor of the order of the term. If order of term is 1, then suffix is 0, which is predecessor of 1. Here the order of the term is 2, then suffix is 1. Here order of the term is 3, and here suffix is 2. So suffix is always the predecessor of the order of the term. We may write tr plus 1 is equal to ncr. Suffix is predecessor of r plus 1 and prefix is n. The second thing we observed here, that is the power of a is always the difference of the prefix and suffix. 0 n minus 0 is n, prefix is n and suffix is 1. So the power of a is the difference of these two. Here in the third term as well, the power of a is the difference of these two numbers. So here in this term we have a raised to the power n minus r. And if we talk about b, so the exponent of b is the same as suffix of the coefficient. If there is 0, the power of b is 0. If suffix is 1, power of b is 1. If suffix is 2, power of b is 2. So here the suffix of the coefficient is r, so power of b must be r. So this is the general term. If we want to write r plus 1th term from the end, because this is r plus 1th term from the beginning of the expansion. So if we want to write r plus 1th term from the end, two jobs should be done. One, replace suffix r of ncr by n minus r. Replace suffix of coefficient by n minus r. And second, interchange the exponents of a and b. So exponent of a will be r and exponent of b will be n minus r. So this is the general term from the end of a binomial expansion. Now let us observe the coefficient in r plus 1th term, that is tr plus 1, that is ncr. This is called coefficient of tr plus 1. So if we want to formulate a relation for coefficient of a general term, let us replace r by r minus 1 in this relation. We get t r minus 1 plus 1. We have replaced r by r minus 1. On the right hand side we get ncr minus 1, and here we have a raised to the power n minus r minus 1 and b raised to the power r minus 1. So simplifying, we may write tr, because minus 1 and plus 1 will be cancelled, and we have tr is equal to ncr minus 1 a raised to the power n minus r plus 1, because opening the bracket this minus will change both the signs, and b raised to the power r minus 1. So we may write coefficient of tr is equal to ncr minus 1. If we are given a binomial with any exponent, we can find coefficient of any term easily with the help of this relation. As for example, 4x plus y raised to the power 15, we need to find out the coefficient of 10th term, So we have to replace in this relation n by 15, because that is exponent of the binomial, and r by 10. So we have 15c 10 minus 1 or 15c9. Later on we may simplify 15c9 and find exact numerical value of the coefficient of the 10th term in this expansion.